find V sub C. Now, because we're asking to find V sub C rather than something more complicated like the voltage across a resistor or the current through a resistor or the current through the capacitor, it seems like this might be an easier problem, but with all these resistors in there, that's what makes it tough. And in particular, it makes tough finding the initial conditions. What's our first step?
First step is to draw for t is less than 0.
That's it. We need to find those initial conditions. And to do that, draw for time less than 0. And what specifically will we find?
You'll find V of C and I of L.
That's it. VC and I sub L, no matter what you're asked to find, you're going to find those guys first. So let's see. Aiden. No, I'm sorry. Sabine, I've got you next. What's your, guide me through redrawing this thing.
So the first part is that the switch is going to be closed and your inductors are going to be shorts.
That's it.
And your capacitors are going to be opens.
Perfect. So that gives us this.
Then I would define what I'm trying to find.
That is perfect. And that brings us back to the fact that we haven't really defined everything we need to define in the original problem. So let's do that right now. We've got a current. Does the arrow go up or down for the capacitor?
It goes down.
Right, because it's got to exit more negative. And let's do the same thing for the inductor. I'm going to arbitrarily draw the arrow to the right just because that seems the way we typically draw things. I sub L, which means we've got to draw it more negative exiting and more positive entering. So another suggestion for you to do is just this: when you get your original problem, draw on there where your V sub C's, your I sub C's, V sub L, and I sub L are. And now there's no question about where everything goes here, because we don't really need to draw that part, but we do need this. Okay. When I see a problem like this, I want to simplify stuff. Is there anything we can simplify? In particular, we've got 5 resistors. Can we simplify any of those guys? Aiden, are any of those resistors in series or parallel?
I'm going to say no.
Right. If you thought any of them were, I would say draw the little green dots to show which part you'd put in your black box. And there's no way that you can draw a black box around any resistors here and have exactly 2 wires coming out. This one's got 3. If you try to draw them around here, well, that's got 3 wires poking out of it. If you try to draw it to the right, that's got 3 wires. Now, in the last class, someone pointed out that you could get really tricky and do that. And now you've only got 2 wires coming out of that. And that's true, you can do that. And that is a valid simplification. But what do you lose if you do that?
You lose what you're trying to find.
One of the things you're trying to find VC and I sub L, and you lose your VC. But you know, we could do that. And since I've got on the solution sheet, I've got a more traditional method where we just kind of give up and we just say, I've got 2 meshes, right? You've got 2 meshes here. You can see you've got the mesh on the left, and you've got the mesh around here. The mesh on the right is 0 by inspection. It can't go through that open. So you could do a mesh with 2 unknowns and 2 unknowns, and you'd write 2 equations. You could do a nodal if you wanted to. Call this guy ground. You'd have a V1, you'd have you've already called this node VC up here. You know what this node is, it's 240. This would be a V2. That wouldn't be a very good choice, right? You'd have 3 unknowns, 3 equations. That would involve a lot of solving. That would definitely be a calculator thing to solve. So I would do it using mesh, and that's the way I did it in the on the solved problems. But just to be different, let's try to do it using using just intuition and using this kind of tricky simplification. We know we're not going to be able to solve for VC at this point, but we should be able to solve for I sub L, and we could rewrite it then as our 11 ohms and our I sub L, and it's going to break into a bottom 70 ohm section and a top, what's the top value?
30 ohms?
30, yeah. And then we'll have an 8 and a big 240 volt source. And now given that, John, just tell me by inspection, what is your I sub L for this? Just read it out for me.
This is going to be 240 times 11 over 30 plus 70. No.
I think you're trying to do a voltage divider.
Okay.
But instead, you just need to use Ohm's law. Ohm's law says that a current is equal to a voltage divided by a resistance. So what's the total resistance that this 240 volt source sees?
111.
111.
No, I forgot the 8 over there. So 100 and
Okay, so the 11 and 8 are definitely in parallel in series, right? So they add.
Mhm.
But then what about that 30 and that 70? What is it doing? Do they add?
yes, because it's going to split, isn't it? And it's going to come back together either way.
And so what is a group of components called when current splits into two and then rejoins at the other end?
A divider, like a current divider.
It is a current divider, but when you're calculating equivalent resistors, what is it when you've got 2 resistors and they're joined at both ends so that the current splits through them, but the voltage is the same across both?
Oh, parallel.
Parallel. So we need to put those 2 in parallel. So that's 30 in parallel with 70. And that's almost correct except for one thing. Jonathan, can you tell me what the one thing that's wrong with that equation?
I don't think I did it that way, but I ended up with 6 for IL.
This will definitely give you 6. But there's one thing that's wrong with both those things. There's one thing that's wrong with this equation, which means it's the same thing that's wrong with this equation. And it's a small thing.
Should it be negative?
Yes. Why should it be negative?
Oh, because the current's going out the negative side of the voltage source, right?
Bingo. That's exactly right.
Okay.
That's an intuitive way of phrasing it. A more rigorous way of phrasing it, I'm going to delete this in a second, but a more rigorous way of phrasing is that you found the equivalent resistance between those 2 points. And when you found the equivalent resistance of those 2 points, it is whatever 19 plus 30 in parallel with 70 is. And then you've got your 240 volt source. But your current is being defined this way. And that's the opposite of the fact that we know that there's 240 volts across it. For passive sign convention, you can only use Ohm's law if it exits the more negative. So we have to modify Ohm's law for this, or we have to modify the 240. We have to say it's either minus 240 if we want to use Ohm's law, or we need to use a new Ohm's law that has a minus in front of it to cope with the fact that the signs are opposite. Just by thumbs up, does that make sense to everybody? Does it not make sense to anyone? Okay. So we now found that Isabel is equal to minus 6 amps. Okay, great. That answers half the problem, but shoot, that answers half the problem, but we didn't answer the whole problem. We found that Isabel is equal to minus 6. But not only did we not find what V sub C is, we destroyed our VC. So now we got to go back to our original problem and do it all over again. Is there anything we can use from this part of the problem that can help us solve what V sub C is?
You know what? If you know what Isabel is, you should be able to find the voltage across the 11 ohm resistor.
Yeah, that's exactly it. If you know you've got this, in fact, you can even do better than that. You know all kinds of voltages in here now. You know that there is 6 amps flowing through here. And that means there's got to be 6 amps flowing through here. Not exactly clear what's flowing through this part. It's going to split, right? Some is going to go up here and some is going to go up here. And we don't know the details of that.
Shouldn't that short be an open?
Shouldn't the short?
Where
Oh,
V
yeah,
sub
yeah.
C
Thank you.
actually is.
I redrew that incorrectly. Thank you. Well, gosh, that makes it a whole lot easier, doesn't it? Yeah, we want to find we want to find our V sub C. And that means that all of our 6 amps has to flow through this. And so now the only question is that some of it's going to branch out and go this way. And some of it's going to branch out and go that way. And if you could find out what the two branches were, you could solve this. You could find all the voltages. I mean, just by inspection, we can see that this is 66 volts. And we can see that this enters more positive, exits more negative. Let's see, I think we said that the value of that resistor is 8 ohms. So therefore, this has to be 8 times 6 or 48 volts. If we knew how much current was going through the 20 ohm, we'd have this problem licked. Is there a way that we can figure out, if you know you've got 6 amps going into a circuit and it's got 2 sets of resistors and the current branches around it and then rejoins, is there a rule for finding out what that current is?
Do a current divider?
It's just a current divider. So without drawing all the extraneous stuff, we've got a 30 ohm resistance on one side, a 70 ohm resistance on the other side, and we've got 8. I don't even have the lack of coffee to blame it on. And we've got 6 amps going into this thing. And we want to know how much current is going around the right side. So what's the formula for that? Who's next? Connor. Wait, did we lose Philip? I haven't called on Philip. Yeah, he's there. I've got a problem with my web. Let me just fix this for a second. All right, Phil, you're next. What's the equation? 1 shot, 1 kill.
So I'm looking for the equation, sorry, for the
Current
The
flowing
voltage
through this
across there?
30 ohm, current flowing through this 30 ohm resistor. Because once we find it, we've now found the current going through this right branch. And once we find that, we know the voltage across the 20. And once we find that, we find VC. And we've done it all without doing any matrix equations.
so wouldn't you just use the current
And what is it?
current divider equation?
Yeah, which starts out at 6 times.
It's going to be the opposite, so 70 over
That's it.
100.
That's it. So let's see, that would be, excuse me, that would be 42,
4.2.
4.2, 4.2 amps. So now that we've got 4.2 amps going around here, now we've solved, I think, everything. You know what the voltage is across this resistor. It's going to be more positive on this side. It's going to be more negative on this side. And it's 42 times 20, which is 84
84.
volts. Yeah. All right. So, Aiden, since you're right there with me, tell me the formula for VC. You can do it. Or tell me the formula how to find VC if you can't find VC directly in one set.
I would do 240 minus the voltage across the 8 ohm resistor minus the voltage across the 20 ohm resistor.
I love it. So you're totally gone the path of intuition. You're saying this 240 is going to build up the pressure on top, which is in the same sense of VC. So that's going to be 240. And then this 48 is going to subtract from it. It's less pressure on top. This 84 is going to subtract from it. And then that gives the entire result of 108 volts. That's great. And that's our answer up here. And that is our answer for the first part of the initial condition. That's great. If you didn't see that, that's all right. Just do a KVL around the right. And when you do the KVL, you get minus 240 plus 48 plus 84 plus VC equals 0, and you'll get the same answer. And so we've solved this entirely using just intuitive approaches without using mesh and without using nodal. And we said the mesh you could do with a 2x2 equation, the nodal would require a 3x3. Before I move on, this I think is the toughest part about it, of the entire problem, this first subpart of the initial conditions. Does anyone have questions about it? And don't be shy. If you do, other people are probably wondering the same thing. Okay. I think if I was to attack that problem, I would probably not use intuition, even though I love intuition. And I probably wouldn't use it because when I got to this first step and realized I'd have to break my VC, I'd realize I'd have to solve two different problems anyway. One to find I sub L, one to find V sub C. And that's a lot of work. And instead of drawing it twice, I would probably just bite the bullet and do the mesh equation. And I've got that solution in the solutions for it.